Hello everyone. Welcome back to AI for Product Managers episode 10. My name is Pranav Harish and this is the last episode for phase 1 foundations. And today I'm going to say something that might surprise you. So not every product needs AI. In fact, a lot of products that have AI shouldn't. So let me quickly get into this. Here is the data, like 40% of features labeled AI powered could be solved with simple if and else conditions or rules. The average AI feature cost 5 to 10 times more to maintain than traditional code. You know that? And here is the kicker, 30% of shipped AI features generate zero measurable ROI, literally zero. So why does everyone keep adding AI? Because of hype, or because investors ask about it, or because competitors slap that AI powered on their marketing, or because it sounds innovative. But your job as a PM is not to add AI, right? So your job is to solve user problems. Sometimes AI is the answer, often it's not. And the best PMs, the ones who ship products that actually work, know the differences. Okay. So today I'm giving you a framework called the AI necessity test. It have 5 questions, a scoring system, and by the end of this episode, you'll be able to objectively evaluate whether any feature actually needs AI or whether you are just adding complexity for the sake of a buzzword. Okay. So a quick note, if you watched episode 1, you saw the 5 question PM framework I have introduced, right? So this episode is a deep dive on that framework. We will score it, weight it, and apply it to the real cases. So if episode 1 was the introduction, today is a workshop for it. So let's get into it. So here is what we are covering today. 5 things. First, the AI necessity test. 5 questions you should ask before building any AI feature. Like this is the core framework. Okay. So second is a scoring system that turns those 5 questions into an objective score. No more gut feelings. You'll have the numbers. And third, 6 scenarios where traditional software beats AI because sometimes the best AI strategy is no longer an AI. And fourth, an ROI framework with real cost numbers so you can calculate whether AI actually pays for itself. And the fifth, scripts for pushing back on stakeholders who want AI for everything, right? Because saying no with data is a lot easier than saying no with opinions, right? So let's start with why this even a problem today. Let me paint a picture that I think a lot of you will recognize, right? If you are in a product planning meeting and the CEO walks in and says, CEO or your VP product, head of product, or director of product, right? So our competitors just announced an AI feature. So what's our strategy? Which sounds familiar for you, right? Or maybe it's an investor call. What what are you doing with AI? They can ask, right? So every company in your space is talking about it. So or some engineering team comes to you excited saying that we could totally use machine learning for this. It would be so cool. They can say that. But here is a problem. None of these are the actual user problems. They are internal pressures, right? And when you build AI because of internal pressure instead of user need, you get features that are expensive, complex, and don't actually make the product better. Okay. So let me give you the reality check. Like AI adds complexity, not simplicity. So every AI feature needs data pipelines, model training, monitoring, retraining, and edge case handling, right? And it won't come for free, right? AI requires ongoing maintenance as well. Unlike traditional code, the works that same way forever, right? AI model drift and data distributions will change, performance will degrade, you are you need a team that watching it constantly. Okay, so AI introduces non-deterministic behavior. So the same input might give different outputs. That's fine for recommendations, but terrifying for billing calculations. And here is a big one. Simple rule often work just as well. I have seen teams spend 6 months building an ML model that performed identically to a 50-line rule engine. Okay, 6 months for zero improvement. So how do you know when AI is actually the right call? Uh, that's the AI necessity test is for. Okay, so here is the framework. 5 questions, each one scored 1 to 5. Total score tells you whether AI makes sense or not. Right? The question one: is the pattern too complex for rules? Can you write if or else logic to solve this? Or are there too many variables and edge cases for it? And question two, do you have enough quality data? AI needs fuel, right? Do you have it, or you hoping to collect it someday? And question three, is the 10x improvement real? Does AI meaningfully beat the non-AI alternative, or is it a marginal gain? Okay. And question four, can you tolerate errors? AI will be wrong sometimes. Is this acceptable in your use case or not? And question five, is there any feedback loop? Can the model improve over the time based on user behavior? Okay. So if you score all of these five high, AI is probably the right call for you. If you score it as low, you are better off with traditional software. So let me break each one down with real examples. So question one, is the pattern too complex for rules? Right? This is the most fundamental question. If you can write a logic in a flow chart, you don't need an AI. So let me give you examples where AI does make sense, like natural language understanding, right? There are infinite ways to say the same thing. You can't write rules for every variation of I want to cancel my subscription, or next the image recognition, right? Millions of visual patterns that no human could enumerate. And coming to fraud detection, fraudsters constantly evolve their tactics, creating new patterns faster than you can write rules, right? Personalization is another great one. Every user is different, their preferences change over the time, and the combinations are like astronomical. You can write a rule for each of your million user, right? Here AI makes sense. And a few more on the AI side, like predictive analysis, where you are weighting hundreds of variables to forecast an outcome. Speech recognition, where which has to deal with accents, background noises, and context. And video recognition, that's image recognition multiple across every frame. None of these fit in a rule book, right? Now here is what AI does not make sense. The price calculations, these are the formulas, fixed inputs, fixed outputs. Eligibility checks, is the user over 18 and in a supported state or not? That's an if statement, right? Not a neural network. And coming to workflow routing, if the priority is high and category is billing, route to team A. That's a lookup table. Coming to data validation, is this a valid email format or not? That is a kind of regular expression, not a machine learning, right? And two more that belong with rules, not AI. Notification triggers. If the balance drops few $50, send an alert. It's just a threshold. And coming to report generation, if it's template based, you are filling in fields, not training a model, right? So here is my rule of thumb. If you can draw the decision logic on a whiteboard in under 10 minutes, you don't need an AI. If you would need a wall-sized whiteboard and still couldn't capture all the cases, AI might be the answer. So score this one if simple rule works for your use case perfectly, and score it as 5 if the patterns are impossibly complex and constantly changing. Now, question 2. do you have enough quality data? This is where most AI projects die. Teams get excited about the model, but they don't have the data to train it, right? So let me give you the minimum data requirement by AI type. For classification tasks like spam detection or sentiment analysis, you need at least 1,000 to 10,000 labeled examples, and they need to be balanced, not 99% one class and 1% the other, right? So for recommendation engines, you need 1 lakh or more user interactions, not user interactions like clicks, purchases, ratings, watch time, and they need to be from diverse users, not just your power users, right? And for NLP and text generations, you need 10,000 or more domain specific texts. If you are building a legal AI, you need a legal documentation, right? If you are building a medical AI, you need medical records. So generic internet text won't cut it. Okay. So for computer vision, 5,000 to 50,000 labeled images, and they need to represent the real conditions your model will face. So different lighting, angles, quality levels. So two more types to know: predictive analysis, predictive analytics needs 10,000 or more historical records with complete features and no data leakage. And that last part trips a lot of teams up, right? So, and the anomaly detection needs like around 1 lakh or more normal examples. So the model learns a clean baseline before it can flag what's abnormal, right? So here is a critical question: do you have this data today? If not, we would collect it. Not, we will get it eventually. Today, because if you don't have the data, you don't have an AI feature. You have a data collection project, and that's a very different roadmap today, right? And also, quality matters more than quantity. So, 1,000 perfectly labeled examples will outperform 1 lakh noisy ones, right? If your labels are inconsistent, your model will be inconsistent finally. So score this as 1 if you have no relevant data, and score it as 5 if you have abundant, clean labeled data that representative for your real use case. And question 3, is the 10x improvement real? This is the ROI question. AI adds complexity and cost as well, right? Is the improvement big enough to justify that? So let me walk through some comparisons like email spam filtering. So rule-based system get about 85% accuracy. AI gets 99.9%. That is massive. That's a massive, right? So clear improvement. User notice like the product is fundamentally better. So AI wins here. And coming to product recommendation, showing popular items get about 2% click-through rate. A personalized recommendation get 15%. So that is 7x improvement at a scale that millions in revenue. Okay, here also AI wins. But now look at a customer support routing, keyword matching gets 70% accuracy, AI classification gets 75%. And that's a 5% improvement. Is that worth the cost of building and maintaining an ML model for this use case? Probably not, right? A better keyword system would get you to 72% for a fraction of the cost. And invoice processing. Template based OCR gets around 90% accuracy and AI extraction gets 93%. So 3 percentage points, right? For a feature that processes maybe 100 invoices a day, the complexity cost far exceeds the benefit. Okay. And one more clear win like content moderation, a keyword block list catches maybe 50% of harmful content. People just misspell their way around it, like AI detection gets you to 92%, like picking up context and intent a block list never could, right? And that's a kind of gap that justifies the investment. And here is my threshold: if AI doesn't give you at least a 2x improvement on the metric that matters, that's probably not worth the complexity. And ideally, if you want 5x or 10x, because you are not just paying for the improvement, you are paying for the ongoing maintenance. So the edge cases, the monitoring, the retraining. So score this as 1 if AI gives marginal improvement over simple alternatives, or and score it as 5 if AI transformatively better. It's going from 60 to 95%. Yeah. So question 4, can you tolerate the errors? This is crucial and often overlooked, right? So AI is probabilistic. It will always make mistakes, right? The question is, can your product handle that or not? So let me give you the error tolerance spectrum. And at one end, medical diagnosis, if an AI misdiagnoses cancer, someone could die, right? So this is zero tolerance. AI can assist here, but a human must always make the final call. Autonomous driving, sorry, near zero tolerance. One mistake at 60 miles per hour is catastrophic. That's why self-driving cars needs billions of miles of testing. Okay. And financial trading, very low tolerance. A wrong prediction could lose millions. Human oversight is mandatory here. So now the other end of spectrum, content recommendations, like moderate tolerance. If Netflix suggests a bad movie, you just scroll past it, right? So minor annoyance and zero harm. There's no harm in it. And email categorization, so high tolerance. If the email gets filed in the wrong folder, you just move it. Easy to fix, low stakes, right? That is one thing. And creative suggestions, very high tolerance. If a writing assistant suggest a bad sentence, you just ignore it. But users expect imperfection here. Okay. So here is the key insight. So low error tolerance doesn't mean you can't use AI. It means you need heavy guardrails. And human in the loop, um, confidence thresholds, fallback system, and all of that add cost and complexity. So if your use case has zero error tolerance and the consequences of errors are severe, AI might not be the appropriate at all. And or it needs so many guardrails that AI part becomes a tiny piece of a much larger system. So finally score this as 1 if error are catastrophic and unacceptable. Score it as 5 if errors are minor inconveniences and that users easily recover from it. Okay. Now question 5, is there any feedback loop? This is what separates AI that gets better over the time from AI that stagnates and eventually becomes a liability, right? So the virtuous AI cycle works like this. User takes an action, model makes a prediction, user gives a feedback, either explicitly or implicitly. That feedback becomes better training data, so you retrain the model, right? So it makes better predictions, more users will engage, more feedback, and better model. So it is again a flywheel, as I explained in our previous episodes. So strong feedback loops. Coming to Spotify, every skip, save, and replay is implicit feedback on recommendations. And Gmail, if you take Gmail, every time you mark something as spam, you are explicitly training the filter. And when it comes to Netflix, watch time is a powerful engagement signal. So Google, if you take Google search, watch results, you click watch result. Sorry, which result you click tells Google which results are relevant, right? So weak or no feedback loops. One-time prediction like loan approvals, you approve or deny, but you don't know for months or years if the decision was right or wrong, right? So batch processing with no user interaction. The model runs and produces the output, but nobody tells it if the output was good, right? And rare events like earthquake prediction, you can't iterate quickly when the event happens once in a decade. Okay. And why does this matter? Because without a feedback loop, your model is frozen in time. It was trained on historical data and it never gets better. Meanwhile, the world changes, the user behavior shift, new patterns emerge, and your model becomes increasingly wrong, right? So score this as 1 if there is no way to get feedback on model performance. Score it as 5 if you have a strong continuous feedback loop that naturally generates the training data. Okay, so all right, so let's put this all together. Here is the AI necessity scorecard. 5 questions, each scored 1 to 5. Let me walk through a real example so you can see how this works in practice. Okay, let's say you are a PM at an e-commerce company and your CEO wants an AI-powered product search. So let's score it with this scorecard. Question 1 is pattern complexity, right? Product search involves natural language queries, synonyms, misspellings, intent understanding. And like red dress for wedding means something very different from red dress casual. I would score this as 4 out of 5. It's complex but not impossibly so. So good keyword search gets you pretty far. Question 2 is data availability. If you have millions of search queries, click-through data, purchase data, product catalogs, which are rich, abundant data, then that's a 5 out of 5. And question 3, 10x improvement. Basic keyword search might show relevant results 60% of the time. AI-powered semantic search could hit 90%, right? That's a significant improvement that directly impacts the revenue. I would give 4 out of 5 for question 3. And question 4, error tolerance. If search shows a slightly irrelevant result, the user just refines their query. So low stakes, that's a 4 out of 5. Okay. And question 5, feedback loop. So every click, every purchase, every back button is feedback on search quality, right? So strong continuous loop. That's again a 5 out of 5. Now the total score is 22 out of 25. That's firmly in the strong case for AI zone. This is a feature where AI genuinely makes sense. Now let me make the score bands explicit because this is the part you will actually use. Like a total of 5 to 10 means don't use AI at all. So traditional software will solve it better, faster and cheaper. And 11 to 18 is the maybe, proceed with caution zone. Okay, AI might help, but build a non-AI baseline first and prove it adds value before you commit. Okay, and 19 to 25, this is a strong case for AI. You have the complexity, the data and error tolerance and make it work to make it work. So our product search example scored at 22, so it lands firmly in the top band. Okay, so let's contrast that, like same company but the feature is AI powered order status updates, like score Q1 1, like it's a database lookup. Q2 is equal to 2, limited relevant data. Q3 equal to 1, no improvement over showing the status. And Q4 equal to 1, wrong status equal to angry customer. And question 5 equal to 1, no feedback mechanism, right? So total 6 out of 25. So don't use AI at all. Just show the order status from your database and see how clear this makes the decision. No gut feelings, no hype, just a structured evaluation here. Okay. Now let me give you a 6 scenarios where traditional software beats AI every time. So scenario 1, deterministic outcome needed. Like tax calculations, compliance checks, billing logic. User needs 100% predictable, auditable results. AI's probabilistic nature is a bug here, not a feature. And scenario 2, small data sets. Under 1,000 examples, there is simply not enough data to train anything meaningful, right? So rules plus human judgment will outperform any model you could build. And scenario 3, real-time constraints. If you need sub 10 millisecond response time, AI inference adds latency, you can't afford it. So lookup tables or cached rules are faster. Uh, and scenario 4, full explainability required, right? So regulated industries need to explain every decision to auditors. The neural network decided it is not acceptable answer. Okay, so rule engines are fully transparent here. And scenario 5, budget under $50K, AI infrastructure, data labeling, and the talent are too expensive. If your total budget for this feature is under $50K, simple software can ship for a fraction of that cost and that work just as well as that. Okay. And scenario 6, rarely changing logic, right? If your business rules change once a year, you don't need a AI model that learns, right? You need a config file that a product manager can update. Now let's talk about ROI. Here is a formula that AI ROI equal annual benefit minus annual cost divided by total investment, like times 100%, right? So one on the cost side, you are looking at data collection and labeling, right? So 10K to 200K, the model development or integration like 50K to 500K, infrastructure is around 5K to 100K per month. Ongoing maintenance comes under 20 to 40% of build cost every year. And don't forget the opportunity cost. What what else could your team have built? Okay. And the biggest line item is usually people, right? The ML engineers run around 1.5K to 1.5 lakh dollars to 4 lakh dollars per person per year, right? And you typically need more than one for sure. And that's often the cost that makes or breaks the ROI. On a benefit side, revenue increases from new capabilities, so cost reduction from automation, user retention from better experiences, so competitive advantage, scale that humans can't match. So my rule of thumb is if the ROI is not at least 200% in year one, the risk probability is not worth it, right? So AI projects have high failure rates, so you need the upside to be the significant to justify the downside risk. Okay. Yeah, coming to the case studies, let me give you some two case studies. One where A was absolutely the right call, and one where it was a waste of resources, right? So case study one is Stripe Radar fraud detection. Here is why A was right. The patterns are impossibly complex. Like fraudsters use millions of different tactics and they evolve constantly, right? You can't write rules fast enough. Okay. The score on Q1 is like 5 out of 5, like the question one. And data. Stripe processes billions of transactions. They have more fraud data than almost anyone on the earth. So I can score it as 5 out of 5 for question 2. And coming to improvement, rule-based fraud detection caught about 60% of fraud while blocking 10% of legitimate transactions. The Stripe radar catches around 99% of fraud with only 0.1% false positives. So, and that's not a 10x improvement, it's a 10x 100x improvement, right? So I can score 5 out of 5 for question 3 as well. Error tolerance, some false positives are acceptable. So a blocked legitimate transaction is annoying but not catastrophic. So for question 4 I can score it as 4 out of 5. And the feedback loop, every chargeback, every dispute, every confirmed fraud is immediate feedback, so the model gets better every day, so I can score it as 5 out of 5. So total 24 out of 25. So this is a textbook case for AI and the rate of return on investment. Like Stripe invested around $10 million plus in their ML team, but fraud was costing merchants around 50 billion annually. So the math is obvious. So coming to case study 2, an AI-powered meeting scheduler, a startup. I'll call them as startup X. Okay. So spend 18 months and 2 million building a custom NLP model to learn your scheduling preferences. So pattern complexity here, the calendar scheduling follows predictable patterns, prefer mornings, block focus time, don't schedule over lunch. These are the rules, right? Not complex patterns. Score on Q1 on score on question one is like 2 out of 5. Coming to data, limited training data. Each user has maybe 50 to 100 meetings to learn from, not enough for meaningful personalization. So for question two, I'll score it as 2 again out of 5. And improvement, their AI achieved 73% accuracy, a simple preference form. I prefer mornings, don't book Fridays, achieved 90% of user satisfaction. The AI was worse than asking users what they want. So for question 3, I'll score 1 out of 5. Error tolerance. If AI schedule a meeting at a wrong time, you miss an important call. Users don't trust AI for high stakes scheduling, right? So for question 4, again 1 out of 5. Feedback loop, which is slow. You only know if a meeting time was wrong after the fact, and rescheduling is painful. So I'll score 2 out of 5. So total 8 out of 25. This should never have been an AI feature. A 2 million and 18 months are wasted, right? A simple rule engine with user preferences would have been better, faster, and cheaper. Okay. So the lesson here is run the scorecard before you commit resources. These two outcomes were predictable from the start. Now, I'll know the hardest part, saying no, right? So because even when the scorecard says don't use AI, you will face pressure from stakeholders who want it anyway, right? Let me give you the scripts. When a CEO says our competitors have AI, we need it too, right? Here is your response. I have evaluated this with our A necessity scorecard. Our use case scores 8 out of 25. Here is what would work better and ship 3x faster. You are not saying no to the innovation, you are saying yes to a better solution, right? So when an investor asks what is your AI strategy, try we use AI where it creates 10x value, specifically in fraud detection and personalization, right? For other features, we choose simpler approaches that ship faster and cost less to maintain. So this shows strategic thinking, not AI avoidance, right? And when engineering says let's use ML for this, it would be cool to say I love the enthusiasm, let's run the scorecard together. Do we have the data? What's the improvement over the rules, right? So let's prove it with a quick prototype first. You are challenging their energy, not killing it. Okay. When marketing team wants to add AI power to a feature, if we can't explain how AI makes this better for users, the label actually hurts the trust, right? So let's focus on the user benefit instead, because users are getting skeptical of empty AI claims. Okay, so the key principle here is always come with data, not just opinions. You are not being anti AI, you are being pro user and pro efficiency. Okay. All right, homework time. Three things I want you to do this week. Number one, score your current AI features. Take every AI feature in your product or planned features and run them through the scorecard. How many actually score above 18? You might be surprised, right? Number two, find one feature to un-AI. Identify one feature where AI adds complexity but not value. Propose a simpler alternative. Calculate the maintenance savings. I guarantee you'll find at least one. Okay. And number three, build your no AI argument. So write one page brief using the scorecard and ROI framework. Practice presenting it. Okay. And because the next time someone says let's add AI, you will be ready with the data. Okay. So now here is something exciting. This is episode 10 and the end of phase 1. We have covered all the foundational concepts. What is AI, how it works, the PM role, data strategy, ethics, build versus buy, and now when not to use AI, right? So starting next episode, we enter phase 2, hands-on AI tools for PMs. Episode 11 is using ChatGPT and cloud to write PRDs 10x faster. We are moving from theory to practice. I'll show you prompt engineering techniques, templates, and a live demo of writing a complete PRD in 15 minutes. Okay. If you found this episode valuable, hit subscribe and the notification bell, share the scorecard with your team, and drop a comment. So, what's one feature in your product that you think might not need AI at all? Okay. Yeah. Let me leave you with five key takeaways from this entire episode. So one is like not every product needs AI. Roughly 40% of AI features could be solved with simple rules instead. Two is like use the 5 question AI necessity test before committing to any AI feature. Three, a scorecard of 19 to 25 is a strong AI case, while below 10 means use traditional software. Four, your AI ROI should clear 200% to justify the complexity and ongoing maintenance. And five is the big one. The best PM know when not to use AI. That's not being anti-AI, it's being a pro user, right? Knowing when to say no is a superpower, not a weakness. That's it. So I'll see you in episode 11. Keep building great products with or without AI. Thanks all.